Hey guys, it's James, and today we're going to be looking at how to balance chemical reactions in the Chemistry 151-5 GLA. We're going to be looking at parts A through D in section D. So the problems read, balance each of the following chemical reactions. In order to balance chemical reactions, we're going to want to make sure that we have the same number of atoms on the reactant side as we do the product side. So we'll go ahead and start out by counting them out. On the reactant side, we have one nitrogen, we have two hydrogens, and we have two oxygens. On the product side, we have one nitrogen, five hydrogens, and one oxygen. To balance out the oxygens, I'm going to add a 2 right here in front of the water molecule. So that's going to change the number of oxygens that we have to 2, but it's also going to change the number of hydrogens we have to 7. So we have 4 coming from here and another 3 over here. So it looks like the nitrogens are balanced and the oxygens are balanced, but the hydrogens are not. Unfortunately, no matter what number I put in front of this H2 molecule, I won't be able to get 7 hydrogens on the left side. So what I'm going to do instead is put a 2 in front of this NH3, because if I can make this number an even number, and this number is already even, the total number of hydrogens will be even, and then I can easily balance that out by putting a whole number in front of this H2. So we're going to go ahead and recount what we have. Now on the product side, we have 2 nitrogens, we have 6, 7, 8, 9, 10 hydrogens, and 2 oxygens. On the left side, we're going to need to put a 2 right here in front of the NO2 to give us 2 nitrogens. Currently we have 2 hydrogens and we have 4 oxygens. So to fix that, we got to go back over here to the right side. We're going to put a 4 in front of this water molecule. Now that's going to give us 4 oxygens. But now we have 8, 9, 10, 11, 12, 13, 14 hydrogens. And how we're going to solve that is we're just going to put a 7 in front of this H2. And now everything should be balanced. We have 2 nitrogens right here. We have 4 oxygens total and 14 hydrogens on the left side. On the right side, we have 2 nitrogens. We have 6 plus 8 hydrogens, which is going to give us 14, and 4 oxygens. So 2, 7, 2, 4 is going to give us the correct answer there. Next up is part B. We have 4 nitrogens, 4 hydrogens, and 4 oxygens. On the right side, we have 2 nitrogens, 2 hydrogens, and 1 oxygen. I'm going to go ahead and start out by trying to balance the nitrogens first by putting a 2 in front of this. So that's going to give us 4 nitrogens. To balance out the oxygens, I'm going to put a 4 in front of this H2O. So that's going to give us 4 oxygens and a total of 8 hydrogens. To balance out the hydrogens, I'm going to add a 2 to the left side over here. So now we have 8 hydrogens and a total of 4, 5, 6 nitrogens. And then to rebalance the nitrogens, I'm just going to change this to a 3. And now it should be balanced. We have 4, 5, 6 nitrogens, 8 hydrogens, and 4 oxygens. On the right side, we have 6 nitrogens, 8 hydrogens, and 4 oxygens. So 2, 1, 3, 4 is how you balance part B. For part C, we have 3 carbons, 8 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, and 3 oxygens. I'm going to start out by putting a 2 in front of this water molecule because I want to make this number of oxygens even, because I know at the end I'll be easily able to balance the oxygens over here. So now we have 2, 3, 4 oxygens and 4 hydrogens. To balance the carbons out, I'm going to put a 3 in front of this. Now we have 3 carbons. The number of oxygens we have has changed, but that's okay because it's still an even number. Now we have 6 plus 2, which is 8. But we don't have a balanced number of hydrogens, so I'm going to go ahead and make this a 4 to give us the 8 hydrogens, but the number of oxygens has also changed because now we have 4 plus 6 is 10 oxygens. Now that we have the carbons balanced, the hydrogens balanced, all we need to do is balance the oxygen. So if I just put a 5 right here in front of the O2, then I will have 10 oxygens on the left as well, and we'll just check. 3 carbons, 8 hydrogens, 10 oxygens. Over here we have 3 carbons, 8 hydrogens, and then 6 plus 4 is going to be 10 oxygens. So 1, 5, 3, 4 is going to be how you balance part C. And for part D, we have 6 carbons on the left, 14 hydrogens, and 2 oxygens. On the right, we have 1 carbon, 2 hydrogens, and 3 oxygens. Again, I'm going to start by putting a 2 in front of this so I can try to get an even number of oxygens that I can balance at the end. So that's going to give us 4 hydrogens and a total of 4 oxygens. To balance the carbons, I need to put a 6 out here. So that's going to change this to 6 carbons. Now we have 12 oxygens plus 2 more, so that's 14. And let's see, to balance the hydrogens over here on the right, I need to get 14 of them, so I'm going to put a 7 out here. That's going to give us 14 hydrogens. But now we have 7 plus 12, 19 oxygens. Okay. Now, no matter what number we put in front of this oxygen, we're not going to be able to get to 19. So one little trick that we can do is we can just double everything. If we put a 2 in front of this, we change this 6 to a 12, and this 7 to a 14. You'll see that everything will end up being even, and we can go ahead and balance oxygens at the end. So now I have 28 hydrogens, we have 12 carbons, and we have 24 plus 14, 38 oxygens on the right. And on the left, we should end up with the same thing. We have 12 carbons, 2 times 14 is 28 hydrogens. And now all we have to do is balance out the oxygens. half of 38 is going to be 19. So if we put a 19 right here in the front, then everything will be balanced. This will then change to 38. And 2, 19, 12, and 14 is going to be how you balance part D. So thanks, I'll see you guys next time.